Hey everyone, let's go ahead and get started with this review on Module 6. So on number 1, 2, and 3, we need to determine whether this is going to be a solid line or a dashed line. And then are we going to shade above the graph or below the line graph? So keep in mind, I'm going to do this the quickest way possible when looking at this. I'm not using any test points on this one, okay? So I know that I have here that looking at this equation, first off, it's in slope-intercept form. So when it's in slope-intercept form, I can find the pieces that I need, like the slope and the y-intercept, in case I need to graph it. I can also determine whether it's a solid line or a dashed line and whether it is greater than or less than. Remember, greater than is same as more than, less than is, well, it's less than, okay? So we have this one here. If I was going to graph this line just in general, this is a positive slope. So that means this graph is going to be increasing from left to right. So if the graph is increasing, and I notice that it is greater than and equal to, so this is going to make it a solid line. And then y values are going to be greater than the line that we drew. Okay, so I'm going to try to highlight this here. Y is going to be greater than that line there. So if it's greater than, then that means that we are going to be shading above the line 1/2 x plus 3. So everything that we're going to shade is going to be in this area. Okay. Now again, we could use the test point 0, 0, but we just talked about it as in if it's greater than, we are going to shade above this line. If it's less than, we are shading below it. Okay. All right, so that's number 1. Let's go ahead and look at number 2. So on number 2, again, it is already in slope-intercept form, which is good because then I know that my y-intercept is 4 and I know that my slope is -4/1. Now, we thought about this, we talked about this, we said we would kind of like it if we could see it as a fraction, so we're going to write this as a fraction. Okay. So the interval or the inequality symbol that I see here is less than. So y is less than -4x plus 4, or y is less than the line that we're going to draw, the line that we're going to graph. Okay. So y is less than the line. Now, if y is less than something, then that means we're going to shade underneath it. So if I have a graph here, this is a negative slope. So that means the graph will be decreasing from left to right. And if it is decreasing, oh, you know what? I didn't even say this. Is it a solid line or a dashed line? It is going to be a dashed line because it is not equal to, and it is a decreasing graph. Then where are we going to shade on this one? Well, since it's y is less than or y is smaller than the graph, we are going to be shading this area here. Okay. All right, so I'm going to leave number 3 there for you to try, for you to practice that one. And let's go on to number 4. So on number 4, we are going to graph this solution set. Well, first off, we are going to practice putting this into slope-intercept form. Remember, slope-intercept form, y equals mx plus b, but we're not dealing with equals. We're dealing with an inequality. So it's going to be less than or greater than, less than or equal to, or greater than or equal to. But the whole goal is to get y by itself. So we are going to take this -6, and we are going to move this to the other side of the inequality. However, before we do that, I want to get rid of the parentheses that are on the right side. So I'm going to go ahead and use distribution first. So I am going to do 1/2 times x and 1/2 times 2. So I will have y minus 6 is less than or equal to 1/2 x, and that's plus 1. Now, y has to be isolated. So now I can take that -6 from this side, move it to the opposite side of the inequality, but over here it'll be a positive 6. So go ahead and rewrite that. Y is less than or equal to 1/2 x. 1 plus 6 makes positive 7. So now we have an equation or an inequality in slope-intercept form. Now we can look at all of that and determine all the pieces that we need. So B is the y-intercept. That's where we're going to start graphing from. We're going to use that y-intercept to graph the slope, positive 1/2. I also know that because it is less than or equal to, this is going to be a solid line that we're going to graph with. And I also know that because y is going to be less than the line, we are going to shade below the line. We're going to shade towards the smaller numbers on the y-axis. Okay, so let's go ahead and graph all those pieces. So we start at 7. From here we go up 1, right 2, rise 1, right 2, right 1, or up 1, right 2. Okay. So when you graph this, I'm going to go ahead and graph a solid line first off, just to make sure I can get that straight. And then I'm going to go back and erase a few pieces because this should be a dashed line. Okay. All right. Nope, this one was a solid line. That didn't help any. That is a solid line. Okay, so now that we've got that, if we're shading below, so it's where the y values are getting smaller. So if y is 7, then here y is 0. Right down here y is -7. So we want to shade below where the y values are less than the graph. Okay. Now remember, all viable solutions can land anywhere in the shaded area, and they can land on a solid line. Cannot land on a dashed line. Okay. All right, so number 5, I'm going to leave that one for you to practice. Let's go on down here to number 6. So on number 6, JoJo's Coffee Shop sells 2 kinds of coffee. The coffee shop must make at least $200 a week. A regular cup of coffee costs $2. A cappuccino costs $5. So if we know that it's $2 per regular cup plus $5 per cappuccino, and she has to make at least $200. So if she has to make at least $200, do we want 200 to be the smallest number or the largest number in our equation? Well, at least means we want it to be the smallest, so the smaller side of the inequality should point at the 200. So we will have 2x plus 5y is greater than or equal to 200. Now, on this graph over here, we are going to be graphing the x-intercept and the y-intercept. So we are going to be talking about coffees on the horizontal line, and we are going to be talking about cappuccinos on the vertical line. Okay. All right, so to find the x-intercept, we're just going to talk about coffees. So imagine that let's see, I'm going to pick up a thicker pen here. Imagine that all we have is x. That's going to be our first equation. Okay? So we would have 2x is greater than or equal to 200. That's going to help me find the point on the x-axis. Now, on the other one, I want the point on the y-axis. So then I'm going to ignore 2x. So what I will be left with is 5y is greater than or equal to 200. So for x, divide both sides by 2. And we have x is greater than or equal to 100. That's the value that's going to go on our x-axis. Then for y, divide both sides by 5. And I have y is greater than or equal to 40. That'll be the value that goes on the y-axis. So x would be 100. Y would be 40. And because it is, the equation is greater than or equal to 200, it's a solid line. And we know that she wants to make more than 200. So this solid line here represents $200. If she sold 40 cappuccinos, she would make $200. If she sold 100 cups of coffee, she would make $200. But she could sell a combination of the cappuccinos and the coffee. So if they're asking us, what is she trying to sell? Would it be more than 200 or less than 200? In this case, it would be more than 200. So we are going to shade everything above the graph. Okay? All right, I'm going to leave number 7 for you. And let's go down to problem number 8. Now, on problem number 8, we are graphing a system of inequalities. That means that there is 2 of them. The first one has that y is less than -2. So I have no x value, which means there's no slope. There's no rise, no run. It's just talking about y. So I know that y can be -2 here. Y can also be -2 here. It can be -2 here. Actually, it can be -2 all the way across the coordinate plane in both directions. So this one here, is it going to be a solid line or is it going to be a dashed line? Well, this one would be a dashed line. A dashed line where y is less than -2. So if it's less than -2, then we are going to be shading below that graph. Now let's look at x. So if we notice that y drew a horizontal line, then that must mean that x is going to draw a vertical line. And x must be 3. So that's 3, 0, or I could have 3, 2, or I could have 3, -2. Doesn't matter. The big important detail is that the x's all have to be 3. All right, so this one here drew a vertical line. And it says x is greater than or equal to, so we have a solid line. And any number that is bigger than 3. Well, 10 is larger than 3, or -10 would be smaller than 3. So we are going to draw lines from our graph towards +10 because x is a greater number than 3. Now, which area are we going to shade in? The area that we're looking for is where both graphs overlap. That's what we're looking for. So we are going to be shading in this region here. All right, last one. Let's go to, or 2 more, right? Let's go to number 10. So on number 10, I have a system of inequalities. I'm going to go ahead and write them both into slope-intercept form. So I'm going to take 4x plus y greater than or equal to 8. So what I'm going to do first is move that 4x to the other side of the inequality. So y is greater than or equal to, instead of +4x, it's -4x plus 8. Now this one is in slope-intercept form. My y-intercept is 8. The slope is -4/1. Okay, so -4, that means we go down 4, right 1. Now this one is y is greater than or equal to, so this is a solid line. And on this solid line, we are going to be shading greater than it, so something that is going up or is above the line. Okay. So there's our first equation. Our second equation is negative 6x plus 4y less than 24. I already know that this one's going to be a dashed line. Move the negative 6x to the other side of the inequality. So 4y less than positive 6x plus 24. Then we are going to divide every number by 4. So I have y is less than 3 over 2x. Don't forget that x. A lot of people are forgetting that x. Okay. Sorry, this is 24 divided by 4. So then that's positive 6. All right, so my y-intercept on this one is 6. The slope goes up 3, right 2. So 1, 2, 3, right 2. If I cannot go up 3, right 2, I can go down 3, left 2. Okay. This one's going to be a dashed line. And y is less than. So we're going to go ahead and draw the arrows pointing down. And there's 4 parts here, okay? So let me color in these 4 parts so we can kind of see them. I have this yellow part. I have this blue part. I have this pink part down here. And then I have the part that I did not shade any color, which is the white part. Which part, actually, let me go ahead and color this in so they all look colored. Which part, or which color, has both arrows pointing to it? Okay? Well, green doesn't have any arrows pointing to it. So then that means it cannot be this section. Pink has just the red arrow pointing towards it, so it cannot be that section. Yellow has the blue pointing towards it, so it cannot be that section. And the light blue has the red and the blue pointing at it, so that would be this section that we are looking to shade. Okay? So you have to turn the equations into slope-intercept form. If you're comfortable finding the x and y intercept, you can use that method as well. All right, but I turn them into slope-intercept form and then graph the y-intercept and the slope from there. Okay, number 12. You are planning a school dance and need to rent chairs and tables. Each chair X costs $2. Each table Y costs $8. You have $200 to spend, so the total cost cannot exceed $200. You also need at least 50 items total, so that's out of the chairs and the tables combined. So if you are trying to plan this, you can have chairs plus tables, and that needs to be 50. Now, is 50 going to be the smallest number or the biggest number if you need to have at least 50? So 50 would be the smallest number. You could have exactly 50 or more than 50, but 50 has to be the smallest number. Now, the second equation. So in the second equation, the chairs rent for $2 each. The tables rent for $8 each. And you have $200 to spend. So it says that you cannot exceed $200. So you cannot go over 200. So you want 200 to be the smallest number or the biggest number? Well, 200 needs to be the biggest number because you cannot surpass it. All right, so first thing is writing our 2 equations. Once we have our 2 equations, we are going to go on to where it says, is 40 chairs and 10 tables a viable solution? Which means, is it a true solution? Well, if 40 is x, we can replace x with 40. If 10 is y, or tables is y, we can replace y with 10. So I'm going to go ahead and rewrite this equation. So I'm going to replace x with 40, and then I'm going to add it to y, which we're replacing with 10. And is that greater than or equal to 50? Yes, it is. It is equal to. So this one here is a viable solution. Now, what if I do the same equation, but this time I check 30 chairs and 5 tables? So if I have 30 chairs plus 5 tables, is that one greater than or equal to 50? And that one is no, this one is not viable. Okay? All right. Work on the rest of these and make sure that you have them ready to submit in class.